Cryptography is the process of encrypting and decrypting messages, or in other words, writing in secret code. It's actually been around for a long time.
Julius Caesar, the infamous emperor of Rome, used cryptography to encode messages for his army. The process he used we now call Caesar ciphers, which I guess makes sense. Basically, if you wanted to send a message, say, Abby, you could replace each letter in the message with a different one by shifting over the alphabet by a certain number. So if we shifted over by 3, A would now become D, B would become E, and in the case of Y, you can circle back to the beginning of the alphabet, so it would now become B.
The key is that only you and the person you're sending the message to know the number you're shifting by, so that they can shift everything backwards when decoding your message. However, if you're clever, you might still be able to crack that code. Luckily, we have computers, which add a layer of complexity. Computers think in zeros and ones, or what we call binary. So, to a computer, our secret message, Abby, now looks like this.
We can shift everything the same way we did earlier, but now with the individual zeros and ones, or bits, so that our message is even more scrambled. But we don't stop there. We can also use what are called bitwise operators. For example, when using an XOR operator, you take the bits representing a letter and a random number. In this case, we'll use 1. If we XOR these together, we get this. Because in the first column, or what we call elements, we have a 0 or a 1, so the computer returns a 1. But in the second, we have a 0 and a 0, so it results in a 0, same as the 1 and 1 in the last column. This is a picture of a fancy cipher that was created by the National Security Agency in 2013 called Speck, and it also happens to be one of my favorite ciphers. It may look a little confusing, but we can already understand a sizable amount of it. Here, X is our input, or our secret message, in binary form. It passes through a circular shift here, just like in Dear Julius's method. And this symbol here means XOR, like our example bitwise operator. When the bits from our message get to this point, we XOR them with a key, like the number 1 in our example, and our final output is represented here by Y.
I think Speck is interesting because it was originally created to replace the current standard of encryption, AES, but in the spring of 2018 it was rejected by the International Organization for Standardization, or as I like to think of it, sent back for revisions. Thanks for watching.